Imagine placing a treat just out of your cat's reach with a string attached to it. What happens next feels like a simple test of intelligence. Your cat bats at the string, perhaps accidentally at first, and the treat moves. A connection is made. But is this a flash of insight? A miniature eureka moment where the cat understands the physics of cause and effect? Or is it something else entirely? This simple scenario is a window into a cognitive world that operates on principles vastly different from our own. Researchers at Kyoto University explored this by presenting cats with a similar problem, but with a twist. Two strings, only one of which was actually connected to the food. A creature with true causal reasoning would identify the correct string and pull it. Yet, most cats chose a string at random. They don't seem to mentally model the physical connection. What they do possess is a powerful intuitive physics for other matters. Drop a toy behind a screen and the cat knows it still exists. That's object permanence. Shake a box that rattles and the cat expects something to be inside, suggesting a grasp of containment. They even seem to understand a basic form of gravity, looking confused when an object appears to float. This points to a different kind of intelligence, one that isn't based on abstract symbols, but is deeply rooted in the physical body. It's called embodied cognition. A cat doesn't calculate the physics of a jump using equations. Its brain runs a complex, real-time simulation using a lifetime of sensory feedback. Its whiskers aren't just feelers. They are a spatial measurement tool, constantly feeding data into its mental map of the world. This is why a cat can navigate a cluttered room in near total darkness. Its problem-solving isn't happening in its head, separate from the body. The body and mind are a single, unified computational device. This profound unity of body and mind helps explain why cats are not natural tool users. A crow might use a stick to get a grub, but a cat's tools are already attached. Its claws are hooks, its teeth are grips, its agility is a lever to reposition its entire body. Why would it need to reason about an external object when its own form is a perfected, multi-purpose instrument? The problems they evolved to solve, hunting prey that is fast, small, and evasive, rewarded instantaneous, reflexive action, not detached, contemplative planning. Their intelligence is optimized for imminence, for the immediate physical challenge. Every animal lives in its own sensory bubble, its Umwelt. The world a cat experiences is not the same as ours. It's a world painted with scents we can't detect, filled with ultrasonic frequencies of prey we can't hear, and defined by movements in low light that are invisible to us. When we give a cat a human puzzle, we are asking it to solve a problem that might not even be perceivable or relevant within its sensory context. The cat isn't failing our test. Our test is failing to enter its world. The real question is not, can a cat solve this problem, but rather, what problem is the cat actually solving based on what it perceives? So let's go back to the string. The cat that pulls it isn't reasoning about physics, it's executing a powerful learning algorithm. Pulling the string is an action. The treat getting closer is a reward. The brain forges a potent link. Action A leads to reward B. This is associative learning, and in cats, it is incredibly rapid and efficient. They are masters of cause and effect, but the cause is their own action, and the effect is the immediate outcome. It's a system that builds complex behaviors not from a single moment of abstract insight, but from chaining together thousands of tiny, successful associations, creating an intelligence that looks like reasoning, but is built from the bottom up. Monotony has grown fast. Nearly 2,700 people have watched in the last few weeks.
yet less than 0.03% are subscribed. It would mean a lot if you joined by hitting subscribe. And again, thanks for watching.